Let us consider this exercise for standardizing normal distribution. We have to calculate the required probabilities, this one and that one, correct to 3 significant figures, and we are given this distribution table. Here we know that this is a normal distribution because we have n, and we remember also the fact that here we have the mean and here we have the variance. Remember, and variance or standard deviation squared. So if we have that, we already know that mean is 6.2 and standard deviation is square root of 6.25, and this is equal to 2.5. This is that we know. We also know that we can use tables in order to find different things. But if we want to find the tables, we need to remember that at the moment I have the phi z table, which is the following, and this is taken from the book, and this table calculates the probability that z is below the certain number. So here we can easily use this part for calculation of this part. But in order to calculate this, we need to figure out how to do it. Here it's very simple. If you want to find the p of then x is smaller or equal than 9.7, you need firstly to standardize. And in order to standardize, we have to remember the formula. If we have x, which has the normal distribution with mean and variance given, then z is equal to x minus mu over sigma. And this is a standard normal distribution. So you can say it like that. And if you have a standardized value, so the standardized value tells us how many standard deviation x is from the mean. So basically we can calculate the standardized value. But if we want to do that, we have to remember that here we have z, but here we have x. And if we want to find p, then x smaller or equal than 9.7, we can firstly say that this is the same as probability that z is smaller or equal than what? And here you need to find the following. You have to find 9.7 minus 6.2 divided by 2.5. So this is what we need to do. And we see that it's going to be probability that z is smaller or equal. 9.7 minus 6.2 is 3.5 over 2.5. So what is that? If we use a calculator, we can try to use a calculator, and we can calculate it like 3.5 over 2.5. I have it 1.4, so it is the same as p when z is less than 1.4. And now we can use the table to find the values. So if we use the table to find the values, so here we can take the table, we can go for 1.4. So here we know that the table works for the values that z is smaller than the given value. And if you have 1.4, we don't have anything else. So this is 0.9192. 0.9192. So let's just take it like this. It will be equal to, I will make it so smaller. It will be equal to 0.9192. And this is the answer, but remember we had 3 significant figures. So if we have 3 significant figures, then here we have 2, we can cut it down. So our answer will be 0.919 is our answer. The next thing is we have to find the probability that x is larger than 9.7. So this is basically the same as the probability that it is z larger or equal than 1.4. And as you remember, when we had the table, here we have the normal distribution sketch. Here you have minus a and a, you have 0. If you want to find p z minus or equal a, then this is that. But if you want to find this part, then this is 1 minus p z smaller or equal than a. So it means that it's going to be 1 minus p z smaller or equal than 1.4. And this is 1 minus 0.9192. And this is 0.0808. So this is the thing, and here there are 3 significant digits only, significant figures, so this one we still shall leave. So this is that answer and this answer for this. Thank you.